Hi, today we are going to talk about graphing logarithmic functions, just the basics of that. So what we need to know is this is the standard way to write logarithmic function. This is f of x equals log with some base b of x. We want to remember that we want b to be a positive number, that's the base, and we also don't want b to equal 1. Other than that, it can be any number. X must be a positive number. You cannot use negative numbers in logarithms. So the domain is only going to contain positive real numbers. So this can be written like this. So let's start with this first function, f of x equals log base 2x. Now, I picked certain values. The reason I used those values and not other values is because these numbers are powers of 2. Because the base is 2, and to make things easy to evaluate without using a calculator and make it easier to graph, it's going to be easier to use with 2. So let's start here. Log base 2 of 8, that's 2 to what power is 8? That would be 3. And this is 2. And this is 1. Log to what of 1 to what, I'm sorry, 2 to what power is 1? That would be 0. 2 to what power is 1/2? Negative 1, and negative 2, and negative 3. Okay? So let's do this. So let's start here. So 8, it's going to give us 3. 4 will give us 2, 2 will give us 1, 1, 0, and then half will give us negative 1, and then 1/4 will give you negative 2, and you're going to see a graph that's going to look like that. Okay. Again, x can be, as long as x, just like it says here, as long as x is a positive number, you are allowed to use that. The only reason I chose these numbers just to make it easier to calculate the y values and to plot the points. But you can use really any number, but then you may need a calculator. The domain is going to be all real, no, I'm sorry, the domain is going to be 0 to infinity. But this function is going to have a range that's going to be all real numbers, because this end goes down forever and this side's going to rise. So the range here is going to be negative infinity to infinity, or all real numbers. It does have an x-intercept at 1, 0. A y-intercept, it does not have 1, because what's going to happen here, this side is going to be approaching the y-axis infinitely close, but because we said that the value of x has to be positive, it will not be possible to cross the y-axis, so you don't have 1. This function does have a vertical asymptote, which in this case is the x-axis, which is going to be x equals 0. And here what we have, when will the function go to negative infinity? What does x have to go? So this side goes to negative infinity here. So that happens when x is getting closer to 0. And when x goes to what, f of x goes to infinity? Well, this side goes to infinity, so fx is going to go to infinity as well. Next example. So now I have log base 3 of x. Again, I picked numbers that are powers of 3 to make things easier to do. Log base 3 of 1 over 27 will be negative 3. With 1/9 will be negative 2, negative 1, 0, 1, 2, and 3. You can easily calculate that because these are all powers of 2. I'm sorry, powers of 3. Alright, we do have an issue with this point. We're not going to be able to graph 27, 3, but it's a valid point, so we'll just start with that one. So 9, 2, 3, 1. 1, 0, 1/3 negative 1, 1/9. So it is going to get pretty tight here. And that's the graph. Again, you can see that it resembles the behavior of the graph we did just before that, so it is expected. So the domain is going to be 0 to infinity. You can only use positive values of x. The range is going to be all real numbers. The x-intercept is going to be 1, 0. We do have a vertical asymptote here also. Every logarithmic function will have one. In this case it's x equals 0. And these two things will match exactly what we saw in the other problem. As x goes to 0, f of x is going to go to negative infinity. And as x approaches infinity, f of x is going to approach infinity. And our last example in this video is going to be this one. So this is log base 1/2 of x. I picked, so since 1/2 is a power of 2, these numbers that I picked here are powers of 2. So 1/2 to what power is 1/8? That would be 3. 1/2 to what power is 1/4? That would be 2. That will be 1. That will be 0. 1/2 to what power will give you 2? You need to reciprocate. That will be -1. And then -2. And then -3. So 1/8, very tight here, is going to be a 3. The 1/4 will give us 2. 1/2 will give us 1. 1 will give us 0. 2 will give us -1. 4 will give us -2. And 8 will give us -3. So if you compare this graph with the first one we did, it looks kind of similar, except it's flipped. It's reflected about the x-axis. The domain is still the same, 0 to infinity. The range is still the same, negative infinity to infinity. We still have our x-intercept at 1, 0. Our vertical asymptote is still going to be x equals 0. But let's see what happens here. So as x approaches what? F of x is going to go to negative infinity. This end goes to negative infinity. So x is going to go to infinity. And as x approaches what? F of x approaches infinity. Well, infinity, the function goes to infinity over here. So x is going to approach 0. Okay? This is how it's done, and I hope this helps.